Welcome to Activity 4.1 out of PS2, and you should be on page 33 in your book. So we're going to go through the directions, and I'm going to get you going on your own. So our learning target today is we will be exploring how an item bounces. So far in this unit, we've taken a look at kinetic energy, Ke. We've taken a look at gravitational energy. Now we're going to add a different type of energy, elastic energy. So elastic energy, let's talk about it. This is the energy that's stored in an elastic material, and it comes as a result of stretching or compressing. So when you pull back a rubber band, that's elastic energy. It's stored there. So if you're pulling it back, it's stored until you release it. This could come from a spring. This could come from a ball bouncing because it gets compressed. Now, the amount of EE, or elastic energy, is related to the amount of stretch or rigidity of the object. So if you stretch a rubber band further and further and further, you're going to have more potential energy. Then we have to look at the rigidity. If you have something that bends really easy, it's probably not going to spring back. It's probably not going to have too much of a snap to it. But if you take something that is really rigid, it's going to have much more of a snap. So for example, they make these rulers that you can bend, that you can twist, and you can move any which way. If we were to pull that back and let it snap, it may not even move back, or it may move back really slowly. But if you take an old-fashioned wooden ruler and you pull it back an inch and let it snap, there's going to be a little sting to that if you were to get hit by that. So let's talk about the activity today. What we're going to do is we're going to use pie charts, energy conversion diagrams. And if you flip over the page from page 33 to page 34, you'll see that there are 6 energy conversion diagrams on the top, and there's 5 on the bottom. So this is how it works. Here's the diagram that I'm supposed to be showing you. And when you look at the diagram and you look on page 34, the top one, circle number 1, that's the energy conversion diagram for this ball right here. And then 2, then 3, then 5, 6, 7. Those are all on the top. But if you look at the bottom, there's 5 more energy conversion diagrams: 4.1, 4.2, 4.3, 4.4, and 4.5. So 1, 2, and 3, 5, 6, and 7 are going to be energy conversion diagrams while the ball is still in the air. But all of 4 is when the ball is in contact with the floor, if that ball's being bounced. So when we look at the energy conversion diagrams, again, here's 1, 2, 3, 5, 6, and 7. So here the ball is dropping, here the ball is moving up. You can see it with the arrows. So what I'd like you to do is draw in energy conversion diagrams for positions 1, 2, 3, 5, 6, and 7. So go ahead, pause the video. It may take you 4 to 5 minutes. Don't forget to create a key and draw an energy conversion diagrams for 1, 2, 3, 5, 6, and 7. And then once you're done, you can unpause the video. So you can pause it now. So now you've had a little bit of an opportunity to draw those in on page 34. And so now if you look at the bottom of page 34, there's a 4.1, 4.2, 4.3, 4.4, and 4.5. So if we go back to this slide, those all correspond to these. This is where the ball is in contact with the ground. So if we look at the circle for 4.1, the ball has just touched the ground. So just as it hits the ground. So draw an energy conversion diagram. How much elastic energy would it have? How much kinetic energy would it have? How much gravitational energy would it have? So here's 4.2. It's starting to compress. So if we go back, that's this position right here. So how much kinetic energy? How much gravitational energy? How much elastic energy? So if we go to 4.3, this is the position right here. This is where it's full compression. So draw in how much GE, how much KE, how much EE. So here it's starting to rebound, and here it's left just as it leaves the ground. So go ahead and complete these. So you can pause the video until you have all of these drawn in. Okay, so you've had a chance to draw them in. Now, one of the things that I'm going to do is I'm going to show you this slide with all the answers. No. Could you copy this down? Yes. But then what I'd be concerned with on a test, would you be able to do it if you just copied? So can you look at an object? Can you accurately figure out, is the energy, what's happening with the energy? Is it going from KE to GE, or is it going from GE to KE? Is there any GE? Is there any KE? So here would be an example of what they would look like in this position. So how did you do? Now if I scroll up a little bit, here was what 4.1 might look like, 4.2, 4.3, 4.4, 4.5. So when we look at all these, again, elastic energy, as it starts to bounce, you're going to have a lot of elastic energy, especially down here. And you might say, okay, why is there no GE? Well, if they're all in contact with the ground, there is no GE for any of those. So because there's no height, there's no elevation. And so your KE is still here, but as it starts to compress, there's less and less KE until finally, when the ball bounces and it's fully compressed, for a split second, there is no KE. It's all EE. And then it goes back the other way, and we start to add more GE as you go up. So how did you do with this? Now, what I'd like you to do is go back to page 33 and answer the conclusion question. Summarize what happens to a ball energy or ball's energy when it bounces. Then number 2, what do you still need to learn in order to explain the bounce? So do you have everything you need in order to explain the bounce? And then 3, do you feel comfortable using energy conversion diagrams to represent how energy changes from one form to another? If not, explain what is unclear to you. And you probably are going to want to ask your science teacher, because on the test you are going to have to draw energy conversion diagrams. So as always, when you finish this up, because you were absent, because you weren't here, show your teacher and make sure that you're done, and make sure you ask any questions if you still have them. Don't wait until the test to realize that you didn't understand activity 4.1. Thanks.